Hi, today I'm going to talk about the computer-based test probability theory. I'll take a question as an example to teach you how to use Excel to solve computer-based tests and probability questions. For this question, we know that it's question 4. Suppose the number of claims n is being modeled as probability of n equal to 0 equals to a. N from 1 to infinity. I'll annotate. This is from 1 to infinity. Given probability of n equals to n, given constant, this is sum of from 4 to 3, n plus 3, divided by n factorial. And we are given the n, the mean, which is 8.432941176. Compute the probability for there are two requirements. The first requirement, we compute the probability, number of claims at least 8. So this is 8 to infinity. The next is the expected of n squared given n is bigger than 0. This we'll discuss this later. So I'll clear my annotate and we straight to go into my solution. Okay. For this solution, like this table shown, we need to find an A. So how to find an A? By using this. So because we know that the probability of n equal to 0 equals to A. So expanding this, we know that because it's from 4 to n plus 3, it is 1, 2, 3. So we need to divide by 3 factorial, and this is 3 factorial is 6. So we can come to this and this line with probability of n equal to n, given constant, n plus 3 factorial divided by 3 factorial divided by n factorial multiply 0.75n. So from this, we can, as for the first step of me, I will expand it like until n factorial and divide it. But for this, we know that this distribution is a negative binomial. Okay, negative binomial, there's a concept of k plus n minus 1, okay, p, k, 1 minus p, n. Okay, so from this, we know that we need, because it's a negative binomial distribution, we need to sum from 1 to infinity given this. Okay, so it's from n plus 3, this is the NCR, n plus 3n, multiplied by 0.75 power of n. So from this, we can know that we need to find the k, because this is the, we have the n, which is 0.75 power of n. So how to find the k? We need to 1 minus it, 0.75. So we can come out as 0.25. How to get the 4? It's because we know that k plus 1 minus 1 equals to n plus 3. So from this, we can know k equals to 4. Okay, so k equals to 4. Stated here, this is k. Because we cannot simply multiply any equation into this, any kind of equation. So when we multiply 0.25 power of 4, we need to divide it back. As we see that this is a constant, so we can take it out and divide it. So when we divide it from 0.00274598 divided by 0.25 power of 4, we calculate it here. We know that the constant is 0.7027450888. So from the table, we have filled all the constants because the constant is the same between from 1 to 8, like 1 to infinity. Because for the table, I just write 1 to 8. But for the n equal to 0, it's nothing. So because there's no constant. Okay, I clear my annotate. Okay, then we'll come to here. After we divide it, we'll come out to here. We calculate the constant, and we have sum 1 to infinity, n plus 3, n. Okay, this is n, this is k. Okay, so how to find the a? Because this is from 1 to infinity. A is probability of n equals to 0. We need to find a by using 1 minus probability of n bigger or equals to 1. So it's 1 to infinity. So how to calculate 1 to infinity? By using the sum from 1 to infinity, given k equal to 1. So this one, come up with this equation. So 1 minus, okay, from this distribution negative binomial, we can come up with 1 minus 0.25 power of 4. And multiply by its constant, we come out, okay, I'll clear my note again. We will come out 1 minus approximately 0.7, like because this is 0.99. So we can find the A which is 0.3 multiple 0, 1. Okay. We're back to my table because we have calculated the A which is the probability of when n equals to 0, which is 0.3. Okay, because there's no constant, so there's 0. For the constant, we know that because for the question, it's at least 8. So I just calculated from 0 to 8. Given constant is the same. And probability, how we calculate the probability? We calculate the probability using, because I stated just now, it's negative binomial. So negative binomial, we use B5, which is the n, which is the constant, sorry, multiplied by negative binomial distribution of n. This is the number of fail. Number of fail multiplied by the number of success. What's the number of success? Given k, just now we calculated is 4. So probability of success is 0.25 because 0.25, 1 minus 0.75, so 0.25. So we don't want the cumulative, so we force. Okay. After getting the 0.002835294, we can just bring it down, and it will auto calculate it for us. This is the good of Excel because it's more easier by calculated. It's more complicated if we like multiply one by one. Okay, now why we need to calculate the n square multiplied by probability of n? This is because for the second one, e power of n square, n bigger than 0. So we calculated this is expected of n square. So how we calculated n square multiplied by probability of n. So we can know that the n square, which is here, it's a5, which is here, square multiplied by the c5, which is the probability. So we can come out with 0.008235294. So same, we can just bring it down all our equations and we auto calculated by Excel. I'll clear my annotate. Okay, after getting this, all the things, we can start to solve our question. For the question 1, compute the probability that the number of claims will be at least 8. So we know that, sorry, it's n. It's at least 8. So it's 8 to infinity. So it's included 8. So how we calculate it? We can use 1 minus probability of n smaller than 8, which is not included 8. This is from 0 to 7, as I stated here. So 0 to 7, how we calculate it? We can 1 minus from 0 to 7. So same. We calculated the 0 to 7, we calculated the answer is 0.501271247. Okay, this is for the question 1. And for the question 2, we need to find the expected of n squared given n bigger than 0. First, we need to know the equation, the variance x on negative binomial. It's k multiply p1 minus p divided by p squared. So what is the p? P is here, 0.25. So we sub it into the formula. We found that it's 4 multiply 1 minus 0.2 divided by 0.25 square. So we calculated the variance. The variance is 48. Next, after we calculated the variance, because we need to know the expected value of n squared, we know that from this formula, variance n given n bigger than 0 equal to expected of n squared given n bigger than 0 minus expected of n given n bigger than 0. This is the mean. Okay, after getting this, we know that because we are given the mean is 8.432941176. Okay, so after getting this, we know that the variance which is 48, we need to find this. So I clear my annotate. Expected of n squared given n bigger than 0, it's the variance n bigger than 0 plus the mean. I'll just write mean squared. So from this, we can find that, okay, the variance 48. So B 28, which is 48, plus the mean square, which is the 8.43 stuff. After we square, we calculated the expected of n squared given n bigger than 0. It's 119.1144969. So this is my solution. For this question, I think the most important thing is we need to know that this is a negative binomial distribution, and some basic concepts on the negative binomial, like the variance x equals to k multiply 1 minus p divided by p squared. And this variance formula is important. So because I think that Excel is very easy for us now because we can calculate many things together. So I think this will help for the people that want to have computer-based tests in the future. So this is end of my presentation. Thank you.